Welcome back, dear students of class 9. So today we are going to discuss chapter 3, and it's the continuation of chapter 3, water. And today's topic is hydrated and anhydrous substances. To understand hydrated and anhydrous substances, first we need to know what is water crystallization. So what is water crystallization? Water crystallization is the fixed amount of water that is associated with some compounds, which is an integral part of their crystalline structure. So, in a simple sentence, now, if we have certain water molecules, fixed number, associated with certain compounds, then those fixed number of water molecules are known as water crystallization. For example, in case of washing soda, the formula for washing soda is Na2CO2 dot 10 molecules of water. Now here, in this particular washing soda, we have Na2CO3 dot 10 molecules of water. This 10 molecules of water is an integral part of this particular washing soda. Okay? This gives its property to washing soda. Therefore, this 10 molecules of water is known as what? Water of crystallization. Hope this is clear. This 10 molecules of water is known as what? Water of crystallization. Okay? Now, once you understand this water crystallization, then we come to hydrated and anhydrous substances. Hydrated, as the name itself suggests, hydrated means water molecules are present. So, those compounds with water molecules, certain water molecules are associated with a particular compound, then those compounds are known as what? Hydrated substances. So hydrated substances contain what? Water crystallization. So this particular compound, washing soda, is a hydrated compound. Okay? Now, anhydrous means it's just the opposite of hydrated substances. Anhydrous means opposite of hydrated substances. These substances, they do not contain water of crystallization in their particular compound. Okay? Those substances which do not contain these certain fixed water molecules in them are known as what? Anhydrous substances. For example, common salt. The common salt that we have, that is NaCl, potassium. NaCl is a common salt. Okay? Table salt, that is anhydrous substance. And we have, say, NaCl. Does it have any water molecule associated in this formula? No. Therefore, it is a what? Anhydrous substance. Similarly, we have potassium nitrate. Here also, water molecules are not present. Therefore, it is known as what? Anhydrous substance. And hydrated will contain water molecules, certain fixed water molecule in them. Hope this is clear. Now, let's move on to next topic. And these topics that we are going to discuss today are very interesting. So the next topic that we are going to discuss today is what? Is efflorescence. So, the next topic that we have is efflorescence. So, efflorescence. Now, efflorescence is a phenomenon. Now, please, if you listen to me carefully, you will understand it. It's very simple. Now, efflorescence is a phenomenon, okay, where certain compounds lose their water of crystallization. Don't forget. There are certain compounds where water of crystallization is not present. Now, whenever they are exposed to atmosphere, okay, when they are exposed to atmosphere, what will happen? They will lose their water of crystallization and result. Excuse me. Whenever certain substances are exposed to what? Atmosphere, then what will happen? They will lose their water of crystallization. And what will happen? As a result of that, they will also lose their shape and finally they will crumble into powder. Please remember. Before losing water crystallization, they were having certain shape, certain crystalline shape. Okay? Now, once they are exposed to atmosphere, means they are kept in open, what will happen? They will lose their water of crystallization. Okay? They will lose it. And what will happen? They will, once they lose it, they will also lose what? Their shape, and finally they will crumble into powder. Such substances are known as what? Efflorescent substances. And here what they are doing? They are losing when exposed to atmosphere. Exposed to atmosphere, they will lose water of crystallization, and also lose their crystalline state and finally crumble into powder. Crumble into powder. So they will finally crumble into powder. For example, washing soda again. Washing soda is one example. What is the formula for washing soda? Na2CO3 dot 10 molecules of water. So once they are exposed to atmosphere, they will lose this water crystallization. Hope this is clear. Now let's move on to the next topic, that is deliquescence. Okay? And deliquescence is just the opposite of what? Efflorescence. If you understand this efflorescence, just the opposite of efflorescence is what? Deliquescence. So the next topic is what? Deliquescence. Deliquescence. Now again, these are, I told you, this is the opposite of what? Efflorescence. Please remember. Now, these are those compounds where certain water-soluble substances, now please listen to it carefully. Certain water-soluble substances, when exposed to atmosphere, what they will do? They will now absorb water molecules. They will absorb water molecule so much that now they will now finally dissolve in it and become and make a saturated solution. So deliquescence is what? Is the phenomenon where certain these substances, when exposed to atmosphere, they will absorb water from the atmosphere, become moist, and after a certain time, they dissolve it in. They will dissolve in it to make a saturated solution. Okay? And the examples are very, very known to you. That is common salt. If you keep your common table salt and it's open for longer period of time, okay, you can put it on the table, keep it open. After few hours, you will see that those crystals now they have turned into liquid form. what they have done? They have absorbed water from the moisture and got themselves dissolved in it. Okay, this is very simple. Now, next topic is hygroscopy. Hygroscopy. Now, this hygroscopy and delicusence, they are almost similar, okay, in definition, but there is one main point of difference. Please listen to it very carefully. Now, these are those certain substances which absorb moisture from the atmosphere. Now, here also same thing happened, here also same thing is going to happen. But now, here in hygroscopy, what will not happen? They will not dissolve it. Please remember. Now, in case of hygroscopy, they will also absorb moisture from the means water vapor from the atmosphere. Okay, they will absorb it, but they will not absorb so much that they will become a solution. Means they will not dissolve in it. But in case of delicusence, what happened? They absorbed so much that they got themselves dissolved in it to become a saturated solution. Okay, please remember. Now, hygroscopic substances, example are calcium oxide, phosphorus pentaoxide. So here, they also absorb moisture from atmosphere, but they will not dissolve so much that they will not form a solution. But in case of this one, here it got dissolved. In case of delicusence, it got dissolved and they formed one saturated solution. Please remember these definitions: efflorescence, delicusence, hygroscopy definitions along with examples. Okay? Please remember them. Now, the next thing that we are going to discuss is dehydrating and drying acids. Okay? So this is very simple. Dehydrating and drying acids. Drying acids or drying acids or dehydrating acids. Now, drying, this is very simple term. There are those compounds which are used for drying other substances. Okay, are known as what? Drying acids. Means this drying acids, this should have certain property, that is to absorb water molecules from other substances. Now, these drying acids are those substances that has this capability of absorbing moisture without chemically reacting with other compounds. Then they are known as what? Drying acids. An example is what? Example is again phosphorus pentaoxide, P2O5, calcium oxide. These are all what? Drying acids. So drying acids, let me tell you once again, are those substances which absorb moisture from other compounds, but they do not chemically react with them. Their work is just to absorb the water. It does not react. It doesn't react. Let's keep it in your mind. Now, the second one is dehydrating. Dehydrating acids. Now, in both the cases, their work is to what? Absorb water molecule. But in case of dehydrating, please remember, now they not only absorb moisture, but they chemically react with what? With those substances, okay, which are kept around it, and if they have, say, hydrogen and oxygen in that particular compound, then they will extract it from there as water molecule. Okay, please remember this one. For example, I'll give you, let me tell you the definition once again. These dehydrating agents are those substances that can remove even the chemically combined water molecules. Okay, if I give you an example, that will be more clear. You know this sucrose, that is sugar, C12, H22, O11. So whenever you treat with, say, some dehydrating agent like concentrated sulfuric acid, what will happen? Now, I told you, they will see, this is sugar molecule. Now, this is a fixed residue and it is a compound. Yes or no? If you use some drying agent over here, they will not be able to extract this H and oxygen from here. Drying agent, I'm talking about drying. Why? Because they will not chemically react with what? Those compounds. But dehydrating agents, whenever it comes to dehydrating agents like concentrated sulfuric acid, now you will see, this will extract this as water molecule, because you know H and O, hydrogen and oxygen gives you water molecule, therefore it will extract that from this particular sugar. And what will be left? Carbon will be left, and it will extract the rest of hydrogen and oxygen as what? Water molecule. See, water molecule has come out, and only this compound is left with only carbon. Now for balancing, 12 carbons go here, and here we have 12 carbons. Here we have 11 oxygen, and double the number of hydrogen atoms. Therefore, if I write 11 here, this equation becomes balanced. Now, see, this concentrated sulfuric acid behaving as dehydrating agent has extracted, chemically reacted with this particular compound and extracted this water molecule. And after the reaction, you can see this was sugar having a different property. After reacting with dehydrating agent, this is the black mass now. Carbon is a black mass, and water molecule has come out. Okay? So this is the difference between, this is the most important difference between what? Drying agent and dehydrating agent. And in your book, you have more differences between drying agents and dehydrating agents. Please remember them carefully. And your homework for today, after this discussion, would be to solve exercise 3B. Your homework would be to solve exercise 3B. Please do it. Do it. Study seriously. All these things which are being taught here, because we won't be getting enough time after school reopens. We will not get enough time to discuss it again. Therefore, study seriously. If you have any confusion, you can ask me. Okay, we'll be seeing you in the next video. Take care till then. Thank you.